Good afternoon, children. The last episodes we have completed the chapter periodic table. Periodic table is the most important chapter in the class 10's chemistry. By in periodic table, we have get a clear idea about all the elements present in the universe. You have get in the periodic table we can see a classification of different elements. The elements are classified into different groups and different periods. This classification is based upon their properties. In groups, we have seen that those elements which have the same properties fall in the same group. Similarly, in periods also we can see a gradual change of properties from left to right. While studying periodic table, we have seen that the elements are generally classified into three: metals, non-metals, and metalloids. Elements are, there are several classifications based on their properties and physical nature, etc. The first and foremost classification is the elements are generally classified into metals and non-metals. In this chapter, we are going to study about a detailed study about metals and non-metals. Do you know where is the position of metals? We have seen that the metals are placed the extreme left side of the periodic table. When you look at the periodic table, on left side of the periodic table, metals are placed. On right side of the periodic table, non-metals are placed. From left to right along a period, the metallic property gradually decreases and the right end become a complete non-metal. For example, the second period, first element lithium is a pure metal, atomic number 3. Next, beryllium. Then came the 13th group, boron. What kind of an element boron? Boron is a metalloid. Then came carbon. Then nitrogen, oxygen, fluorine, and neon. These lithium and beryllium are purely metals. They are left side metals. Then there is gradual change. After middle, the 13th group, we can see boron. Then the next element, 14th period came. Which element? Carbon. It's a non-metal. Nitrogen. Then the metallic character decreases to metalloid. As the metallic character decreases, the non-metallic character increases. Where the change takes place in the case of the second period? Boron. Left side of the boron, metals. Right side of the boron, non-metals. Boron is a metalloid. So we can have a broad classification of elements into metals and non-metals. In the period table, we have seen that there are about total elements 118. Out of these 118 elements, more than 90 elements were metals. About 22 elements non-metals, and a few metalloids are also seen. In this chapter, we can see what are the metals, why they are called metals, what are the properties of the metals. If there are any exceptional metals which show some exceptional properties, or there are any exceptional elements in their physical properties with that of the common general properties of the elements. Let us see some of the element metals, why they are called metals. In the period table, we studied the standard ions. In the previous class also, we have studied about ions. What are ions? We all know that atoms are electrically neutral. Why? Atoms are electrically neutral because the number of protons and the number of electrons are same. For example, sodium atomic number 11, it contains 11 protons, that means 11 positive charge, and 11 electrons, that means 11 negative charge. So the net effect is 11 positive charge, 11 negative charge. The net effect is the atom is electrically neutral. But when the ions are formed, when sodium combines with chlorine and sodium chloride is formed, sodium gives one electron to chlorine atom. Sodium atomic number 11, number of protons 11, number of electrons 11, and the electronic configuration is sodium K shell contains 22 electrons, L shell 8 electrons, and N shell 1 electron. 2, 8, 1. Why it combines with the chlorine? What happens? Chlorine electron configuration 2 and 8 and 7. Sodium atomic number 11. This is sodium atom. This is chlorine atom. Chlorine atomic number 17. Electron configuration 287. While sodium combines to chlorine, what happens? Sodium gives 1 electron to chlorine. Why sodium combines with chlorine? To attain stability. When sodium gives 1 electrons to chlorine, this is sodium atom 2A. When it combines to chlorine, it gives 1 electrons to chlorine, it becomes an ion. So 2A. This 1 electron goes to sodium. Then it acquires a positive charge. Why? While sodium is in the atom stage, number of protons and the number of electrons are same. Protons and electrons are same means positive charge and negative charge are equal. Can see this right? Then what happens? When it's combining with the chlorine, it gives 1 electron to chlorine. When 1 electron is gone, it means 1 negative charge is gone. Then there is 1 positive charge excess. So it is positive charge. This is sodium. The sodium. What is the difference between sodium atom and sodium ion? There is two differences. What is in sodium atom electron configuration is 281. The sodium ion electron configuration is 2A. But second difference, sodium atom is electrically neutral, but sodium ion is positively charged. It gets, but how it gets positively charged? Now here by sodium ion, number of protons 11, number of electrons 10. Then excess of one positive charge in system. Similarly, this is chloride atom. Chloride atom 287. When the chloride ion what happens? 288. It gets an additional electron. So it is negative charge. This is chloride atom. This is chloride ion. It is negative charge because an additional electron it gets from the soil. This atom and atom. Now, my question is that what is the major difference between metal and non-metal? This is the major difference. What is this? Metals always gives electrons to donate electrons to the non-metals. Metals never accepts electrons from any other elements. Metals are the donor of electrons, gives electrons and become positive electrons. We can have definition also. Those elements which gives electrons. Non-metals on the other hand, it always accepts electrons. There are some exceptional cases we can study later in the class. Metals take part in chemical reaction, it gives electrons. Non-metals, on the other hand, by take part in chemical reaction, it accepts electron. In this class, we are going to familiarize some metals in your surroundings, in your home, and we can have a close look at these metals and their properties, common properties, what we can see. What is the main metal in your home? We can see a number of metals. I can show you some metal. This is one of the metal. What is this? This is iron. This is iron. We can see another metal. This is copper. Cu. This is copper. Can you see another metal? This is magnesium. This metal is magnesium. This is magnesium. Magnesium, iron, copper. Then I can show you one more metal. What is what is this? This is clinical thermometer. Clinical thermometer. Where is used? It's for measuring by you have got fever. You go to hospital. And they measure your temperature using this thermometer. How do you ever think how they measure? You can on a close look. You can have seen that a narrow thin line inside the meter. This is clinical thermometer. So that means also thermometer which is used for measuring the body temperature. Measuring the body temperature. So it's not clinical. How in which unit is used to measuring the body temperature? Is it degree Celsius or Kelvin scale? No. In body temperature is measured using the unit Fahrenheit. What is the? Do you know what is the minimum body temperature? Normal body temperature 97 degree Fahrenheit. I said to that a narrow thin line inside the thermometer. Which material is narrow thin line? That is mercury. What's simple? Hg, mercury. The narrow thin line, you can see is mercury. What is mercury? What's mercury? Why mercury is used here? Mercury is the only liquid metal, only liquid, the liquid stage. Mercury is the liquid stage. While we it's placed in this is the mercury. You can see the bottom. When measuring place your hand here. This metal expands. It's a liquid state, and if there is any temperature in your body, this mercury expands, and we can see there's a rise in the temperature, rise in the degree of Fahrenheit. Then the clinic or the says that the pharmacist or lab assistant says that you have a temperature. You have a temperature that it shows the symptoms of fever. But why I show this? The only liquid metal, which is the only liquid metal which is one liquid state, is mercury. Where this is the one use of the which metal is used in thermometer. All thermometers we use in thermometer. Which metal is used? Mercury. What is the symbol of mercury? Hg. What's the Latin name? Hydrogen. Not the mercury symbol is not Me. The symbol of mercury is Hg. Why? It is the Latin name of mercury is hydrogen. So we can see we have learned some important metals here. What are the metals we see here? Iron. Symbol Fe. Why the symbol iron? The symbol of iron becomes Fe. The ninth standard, you studied that the names of the symbol is the short form of their chemical name. Symbols are the short forms of their chemical name. The names came from their names in Latin, Greek, or German language. And in the Latin name, iron is ferrous. So its symbol is Similarly, mercury symbol is Hg, because in copper symbol is Cu. You can see another metal also. This is aluminium. The thin shiny metal is aluminium. This is aluminium. It is used in the what is the main use of aluminium? For cooking vessels. Then we can see what are the common properties. Can you say some of the names of non-metals? Some of the non-metals we can see are carbon, coal. The next day we can show you the coal. Carbon, the main constituent. This is iron. Some non-metals, the solid states are carbon, sulfur, oxygen. That means all those elements on the right side of the periodic table are non-metals. Carbon, sulfur, etc. What are the most important properties of these metals? We have seen that first, have a shiny appearance. Shiny appearance. This shiny appearance is known as lustrous. If a corroded a piece of rust iron is and we rubbed with the sandpaper, it also gets that shiny appearance. The shiny appearance is known as lustrous. All metals are lustrous. All metals are hard. If it is a hammer, no change at normal conditions. They are hard. Then they are what is lustrous. Then can you say other properties? This is aluminium sheet. How this is produced? The aluminium material is it's beaten into thin sheets. At the same time, a carbon or sulfur is beaten, it changes into powder. When metal is beaten, it is taken with a thin cheese. This property is known as malleability. Malleable. Then can another property of metals? In electric wires, we have seen thin, narrow wires of metals. That means the metal can be thrown into thin wires, thin fibers, thin wires. This property is known as ductile. Then can you say another properties? You have all heard that before the beginning of every school hours, we hear bell. How it is produced bell? Even on a metal, if we hit it with another metal, we get a sound. This sound is known as sonorous. On the same, otherwise, if we hit with a non-metal, a wood with another metal, it does not produce sound. Only metals can produce sound when it is hit with a hammer. This property is known as sonorous. Then we can see, can you say other properties? In your kitchen, do you wash with which material the cooking vessels are made of? Nowadays, the cooking vessels are, almost all the cooking vessels are made of steel. Steel is an alloy. Steel and aluminum vessels are used for cooking purpose. Why? They easily conduct heat. At the same time, the electric wires. Do you know how electricity is pulled to our school from the road? Using iron rods, and they are not plastic or fiber. So they are conductors of heat. They are hard. These are the general or common properties of metals. There are some exceptional cases also. In the exam point of view, you have to study the general properties as well as those metals which show exception to these properties are remembered clearly for writing the examination. Can you list out the important general properties we have discussed here? First, what are the other properties of metals? They are hard. Second, the shiny appearance of the metals are called lustrous. Third, they are malleable. What is malleable? Do not confuse between malleable and ductile. Malleable means beaten into thin sheets. Is known as malleable. Beaten into thin sheets is known as malleable. What if it ductile? Thrown into the molten metal is thrown into thin wires. That is known as ductile. Yeah, ductile. That means that what happens when you hit it with the hammer, it produces sound. It is known as sonorous. So, whenever you hear the sound or the from the nearby temple or a church, you remember that it is the property of metals. Only metals can produce that property is known as sonorous. Then you can list out a number of properties. What are they? They have high melting point. High melting point. They have high boiling point. They have high melting point, high boiling point. Can you say that again? They are good conductors of heat and electricity. Conductor of heat and conductor of electricity. Can you say why they are conduction heat and electricity? Since there are free electrons in a metal molecules. In a metal, there are free electrons. These free electrons allow the passage of electricity through it. Can you, in your textbook, there is a experiment in a stand, a pin is to be here, placed here using a wax and heat one end. At some time, the wax melted and the pin is dropped out from the. Why this happens? On heating this end, the heat is transferred to this end. So it's a good conductor of heat. So we can remember the general and the common properties of the metals. There are one more they can say that they are almost all the metals are solids. You can say one is they are first and foremost solids. These are the metals, common properties of metals. Then our aim is there are some metals which are exceptional cases in their properties. The first metal you remember is the only liquid metal at room temperature is mercury. All other metals are in the solid state. Then we have studied that the metals have high melting point and high boiling point. But there are two metals, namely gallium and cesium. If we take gallium and cesium in your hand, what happens? It melts. The melting point of gallium and cesium is 28 degrees centigrade. So at room temperature it melts. They have low melting and low boiling. Then we have says that all the metals are very hard. All the metals are very hard. But at the same time, there are two metals. They are soft. For example, which are the soft metals? The one of the soft metal is sodium. You can do the experiment. The near glass. This is sodium metal. It is soft. It is very so we can cut it with a knife. In sodium and potassium, though they are metals, we can remember some of special qualities, the special properties of these metals, sodium and metal. One, the first and most important is they are soft metals. The second thing is, can you know where it is kept? It is kept in kerosene. It is kept in kerosene. Why? It reacts with cold water. It reacts with the only two metals which reacts with cold water and it produces hydrogen. So we can ask a question from this session: where is sodium and potassium are kept in? Sodium and potassium are kept in kerosene. Why? They react with water and oxygen present in the air. They are highly reactive. Sodium and potassium are highly reactive. So if we keep the metal in an empty bottle, it reacts with water and moisture present in the air. We can't touch it with our hands. If we touch it with the metal with hand, it reacts with the moisture present in our skin. So we can never touch it with the metals. We take it with using a fork. We never touch the metal sodium and potassium, because if we sodium and potassium touch with our hands or fingers, it reacts with the moisture present in the fingers, skin, and there is a chance to burn. Then we can see, so there are three things you have to remember is, first, the two soft metals, sodium and potassium. Why they are kept in kerosene? They react with oxygen and water present in the air. So they can't keep it in air or in water. You can keep it in only the kerosene. The third thing we have to remember is the metals which reacts with even cold water. Sodium and potassium react with cold water to produce hydrogen. And solution becomes sodium hydroxide. Then these are the common properties you can see in the case of metal. So the first thing you have to do is, in your home, in your kitchen, and there are a variety of metals. You can see the finger ring, which metal is made up of gold. In your gold and silver, they are the metals which are used for making ornaments. So first you in your wrist phone, after the viewing this video, you list out the metals, their symbols, name, symbol and main usage. For example, gold, symbol AU. What is the main usage? Making ornaments. Silver, symbol AG. It is also used for making ornaments. Then aluminium, symbol AU, symbol AL is what's the main use of aluminium cooking vessels. Steel is not a metal, it's an alloy. What's an alloy? Alloy is a homogeneous mixture of two or more elements. One of them is at least metal. In steel, the contents are iron and carbon. Then which metals are the most malleability and malleability means beaten into thin sheets. Which has the high quality of malleability? Copper. Gold is the metal which has the high quality of malleability. The metal which has high malleability is gold. Similarly, the metal which has the best conductor of heat and the least bad conductor, good conductor of heat, and the wants to you have to look, you have to read the test and point out and select the good conductor of heat, bad conductor of heat, good conductor of electricity and bad conductor of electricity. So you have to write down the general properties of the, first you write down the metals in your home and you have seen in your surroundings. You can see this out. Also in that gold, silver, aluminium, where you can see zinc, where you can see zinc. In your home, where in tricell, but what is tricell? Torch battery. No, never say battery is a group of tricell. In the back side, you can see the metal used is zinc. So, gold, silver, aluminium, copper vessels, iron, zinc. Then we can see use the tungsten. Where is tungsten? The metal tungsten, the filament of ordinary bulb, not LED bulb. What is which metal is used? Tungsten. So we can list out these metals. First, you list out these metals, symbols and their uses. Then, the common properties. These are the common. You can see 10 common properties. First one is solids. They are hard, they are lustrous. What do you mean by lustrous? The shiny appearance on the metals is shiny. The metal is lustrous, malleable, beaten into thin sheets, ductile, thrown into thin wires. Sonors, it produces sound when it hits the metal. High melting point, high boiling point, good conductor of heat and good conductor of electricity. Then the third thing you have to write down is those metals which are produced shows exception to these general properties. That means first the liquid metal. Second, the metal which has low melting and low boiling point. Third, the metal which has the great malleability, the metal which has the great ductility, the good conductor of heat, bad conductor of heat, good conductor of electricity and bad conductor of electricity. You already listed these all things. Then we can pass on to the next non-metals. As in that non-metals are those elements which receives electrons from the metals while taking part in chemical reaction. While taking part in chemical reactions, non-metals accept electron and become negative ion. Then non-metals, can you say, I already said you that out of 118 elements, 90 elements were metals. About nearly 22 elements non-metals, and the remaining elements are metals. These 22 elements may either found in either solid, liquid or gaseous state. Can you list out some of the metals, some of the non-metals found in gaseous state? We can't see it. We can't see it, but we can feel it. Can you say, if you close the nose with the subject, what happened? What happened? Air doesn't. Air means what is the main meaning? Oxygen. We does not get oxygen. We can't remain for more than 2 minutes. Because though we can't see the oxygen, we can feel it, the presence of oxygen. Out of these 22 non-metals, they are found in, some of them are found in solid state, some of them are the liquid state, some of them are gaseous. You can find examples for each. Hydrogen, what are the main components of atmosphere? We all studied several times. 78% nitrogen, 28% oxygen, the remaining 2% are hydrogen and inert gases, etc. They are non-metals. These are which state? They are the gaseous state. Can you say any non-metal which is found in the liquid state? The only non-metal which is found in the liquid state is bromine, BROMINE, bromine. Fluorine, the 17th group elements. 17th group elements, fluorine, chlorine, bromine. This bromine is found in the liquid state. Can you point out some non-metals which is found in the solid state? Carbon, sulfur, iodine, etc. are found in the solid state. So, generally, almost all the metals are solid state. Metals are the solid state. But in the case of non-metals, they may be either in the solid or the liquid or the gaseous state. But in the case of metals, the only non-metal which is the liquid state is mercury. Similarly, the only non-metal which is found in the liquid state is bromine. Then we can say that we are familiar with the carbon, sulfur, etc. What will happen when it is heated with them? We are discussing about the general properties of non-metals. The non-metals are found in either the gaseous, liquid or solid state. The only non-metal which is found in the liquid state is bromine. Similarly, the non-metals are not hard. If you beat it with a hammer, it is powdered. It can't be beaten to thin sheets. It can't be thrown into thin wires. So, we can generalize the common properties. What are they? The non-metals are not hard, not malleable, not ductile, nor conductors of heat or electricity. They are not lustrous. Non-metals are not lustrous. That means they have no shiny appearance. But only one non-metal which has a shiny appearance is iodine. So you must remember the name iodine, which is lustrous. That means have shiny appearance on its surface. So comparing to, you can have a general comparison about the common properties of metals on one side and non-metals on other side. First, we are going to compare the properties of metals and non-metals. You have to, under the metals, we write the common metals you are familiar to, like iron, aluminum, etc. Under the name of non-metals, you write the names of some elements like carbon, sulfur. They are the common non-metals. Then we can list out, on looking these two sections, we can point out the common properties on both sides. Then compare them. Then our major aim is those elements on both sides. That means on the metal side and either non-metal sides, which shows exception to these common properties that you have to learn them. Then the previous classes we have already studied that metals form basic oxides and non-metals form acidic oxide. That means sodium when burns sodium oxide, it dissolves in water, sodium hydroxide. It is a base. When carbon burns into oxide, carbon dioxide, it dissolves in water, carbonic acid is produced. Metals form basic oxide, non-metals form acidic oxide. So let us conclude our session here. You have to read and generalize these properties. Not learn by head, learn by heart. You touch it and study it, the properties. Then you never forget the properties of metals or non-metals. You can see the next class. Okay, thank you.